I'm David Denault.
And I'm John Gomez. Stand by for part two, Destination Mars. Rocks from Mars and a Martian monolith.
This is a special report from About Space Today.
Welcome and thanks for joining us today. If you listened to our first report on Elon Musk's vision of colonizing Mars and NASA's search for possible life on the red planet, we've recently learned about meteorites from Mars. David, you interviewed Dr. Tanya Harrison, a Martian meteorite scientist.
Well, I was quite surprised learning that we already have recovered hundreds of Martian meteorites, and that's according to Dr. Tanya Harrison.
So Martian meteorites are rocks that came from Mars, and we found them here on Earth, and we found 235 of them so far. And this is really interesting because we don't have any samples that we've ever brought back from Mars with any of our robotic missions, and so these are the only pieces of Mars that we actually have here on Earth. They were launched off the planet by probably giant impacts. So an asteroid traveling through space smashes into Mars, launches all sorts of debris all over the place, and some of that manages to escape the gravity well of Mars and make it all the way to Earth. And then it lands somewhere here on Earth where people combing either the deserts of the Sahara or the ice of Antarctica, they can find it and then bring it to a lab so we can determine where that meteorite came from. When I actually get to see a Martian meteorite, it's really exciting because it's a piece of another planet that has come 200 million miles through space to us here on Earth. When we sent the Viking missions to Mars in the 1970s, we were able to analyze the composition of the Martian atmosphere. And these meteorites that we have on Earth, we know they came from Mars because they have little trapped gas bubbles of the atmosphere of Mars inside of them. And it's very different from the atmosphere of Earth. So there's no other way to explain how those gas bubbles got in there. And if we didn't have that data from Viking, we would never have known that these meteorites came from Mars. Generally, we can tell from the composition if a meteorite came from Mars, even if it doesn't have the little trapped gas bubbles in it, because they look very distinct and they generally fall into three categories: shergottites, knocklights, and chassignites. And those are all very different from the regular meteorites that we get from asteroids that are just, say, in the asteroid belt. All of the meteorites that we have from Mars tend to be volcanic, so basaltic rocks that are kind of like the stuff that flow out of the volcanoes on Hawaii here on Earth. And so that doesn't tend to be very magnetic, and so if you saw it just laying out on the ground on Earth, you wouldn't necessarily be able to tell visually that it was different from a volcanic rock that just came from here. The meteorites that we have from Mars show us a lot of pieces of the history of the red planet. Things like hydrated minerals, so stuff with water in it, other types of things that are good chemicals for life to thrive. And we see pieces of that with stuff we've analyzed with the rovers and the orbiters, but we can do a lot more scientific analysis in labs with those physical samples with the meteorites here on Earth, with machinery that we either can't miniaturize to a rover platform, or it's just too expensive to try and do that. I really hope that we get to see humans walking on Mars in my lifetime, just because I want to see some of the big questions about Mars answered, because I really just want to know the big picture. I want to know what it all means, where it all came from. I don't think I'm ever going to go to Mars, but I at least want to see people go there.
One of the new instruments on the Curiosity rover has the ability to analyze rocks with a laser. David, didn't you do an initial report on the Gamma and water discovery?
The Curiosity rover carried CamCam to Mars in 2012. And now let's learn of its discoveries and recently found proof of past life on Mars. So what is CamCam and what does it do?
I'm Roger Wiens. I'm a senior scientist at Los Alamos National Laboratory. I am the principal investigator of the CamCam instrument, which is on the Curiosity rover exploring Mars. I'm also the principal investigator of the SuperCam instrument. CamCam is a revolutionary instrument that is designed to remotely and rapidly investigate the composition of rocks and soils anywhere within about 25 feet of the Curiosity rover. CamCam has a powerful laser that takes the energy of 1 million light bulbs and projects it into a spot the size of a pinhead, and it does it for 5 billionths of a second. And with that, it creates a little plasma. Then we can look at these plasmas with a spectrometer, which tells us the color spectrum, which tells us the composition of these rocks and soils that we want to analyze. Since landing on Mars, ChemCam has analyzed almost 1,500 rocks and soils along the rover's traverse. SuperCam has two new techniques that are both designed to tell us the mineralogy of the targets. And so this is very important for understanding where these rocks and soils came from and what kind of history they went through. People want to know, why would we want to explore Mars? But we could be standing here 120 years ago asking the very same question about why in the world would we want to explore human flight.
And most recently, ChemCam discovered a rock from a river
instrument on the Curiosity rover. We were in an area of Gale Crater and we decided to pull up to an outcrop just to see what was around. And part of the outcrop actually had these weird little fins sticking out of it. So we figured, why don't we shoot one of these with ChemCam and see what it's made out of. When we looked at the data that we got back, we realized these had to be manganese oxides because the abundance of manganese was so high. Oxides are a family of minerals that only really form in very specific environments. We were so excited to find these high manganese concentrations because this isn't something we ever expected to see on Mars. So manganese oxides require two things to form. You need a water and you need a lot of oxygen or some other oxidant. When you look at the terrestrial geological record, we actually don't see manganese oxides until after the rise of photosynthesis.
Mars currently appears to be a barren desert with riverbeds, deltas, and deep ocean basins pointing to the water that once existed there. However, a recent discovery has experts both excited and perplexed. Scientists are ecstatic after discovering tons of secret water on Mars. Is it because it denotes the presence of life? Or are we just a step closer to conquering Mars? A robotic rover recently discovered enormous amounts of water beneath the surface of Mars, which surprised many people who had previously thought of Mars as nothing more than a rocky and dusty planet. Mars is one of the most fascinating planets in our solar system. Mars is a world unto itself. One theory suggests that there was once life on this planet billions of years ago because the surface is solid. This red planet has been a popular subject of fiction and science fiction, but it is also a hotspot for researchers. The surface of Mars appears to be dry at the very least. Researchers, however, believe that up to 99% of the water is still present. Instead of escaping into outer space, it sank into the Martian sand and sandstone. All of Mars's primordial water had to go somewhere when the planet's atmosphere collapsed. Since 1997, NASA has landed 5 rovers on Mars, 2 of which, Curiosity and Perseverance, are currently active and investigating the planet. Reconnaissance, MAVEN, and a slew of other human-built spacecraft have been launched into Mars's orbit. Scientists are ecstatic about a new discovery found by one of these orbiters. The ExoMars orbiter of the European Space Agency has identified substantial volumes of water in the Val Marineris Canyon, the solar system's largest known canyon. According to experts, water ice could account for 40% of the near-surface material in the region of 15,830 square miles, that's 41,000 square kilometers. Data from the Trace Gas Orbiter's TGO Fine Resolution Epithermal Neutron Detector, or FRIEND for short, discovered exceptionally high levels of hydrogen, which, coupled with oxygen, makes up water. Mars may have harbored life at some point in its history, and evidence of water could be a key indicator that the planet was previously habitable or that life may still exist there. However, it's crucial to note that this specific finding holds significance for 2 reasons. The vast majority of Mars's water is found frozen near the planet's poles. It's possible that this newly discovered water is likewise frozen, but because it's closer to Mars's equator, it's more likely that the water keeps evaporating. Water can be detected as deep as 3.28 feet or 1 meter below the Martian surface. The fact that it is so much closer to the Martian surface than previously thought makes this new water discovery all the more interesting.
So, John, what are your thoughts about these new findings? Water?
Well, where there's water, there's oxygen and hydrogen, and those are the two biggest things you need to create life. So we have a starting point.
All right, talk to me about that. Water and converts to oxygen and hydrogen. And what are we
Well,
going
it's 2 parts hydrogen, 1 part oxygen.
So what you're saying is we can now go somewhere, if we can find water on any of the planets, that we can sustain life and also convert that for fuel for our rockets.
That's absolutely correct. And that is something that Elon Musk has said is his long-term goal is to put Starship on the moon, use refueling with H2O, and then use the moon as a jump point, depending on the Mars orbit cycle, to jump to Mars.
Well, as you know, I've had the opportunity to interview the second man to step onto the lunar surface, Buzz Aldrin, after he had returned. And recently, Aldrin claims that there is a monolith that exists on one of the moons of Mars.
Explore the moon and develop the moon. We should go boldly where man has not gone before. Fly by the comets, visit asteroids, visit the moon of Mars. There's a monolith there, a very unusual structure on this little potato-shaped object that goes around Mars once in 7 hours. When people find out about that, they're going to say, who put that there? Who put that there? Well, the universe put it there. If you choose, God put it there.
Well, David, true or not, seeing will be believing by our Martian astronauts. I'm John Gomez, and thanks for joining us for Part 2, Destination Mars. And if you liked our programs, make sure you like and subscribe and give us a follow.
Next week, we're remote viewing our government spying. And from Florida Space Coast World Headquarters for John Gomez, I'm David Denault.
This has been a special report from About Space Today.